Assalamualaikum and greetings to everyone. We are from Group 6. We'll present about the experiment to flow measurement. And our group members are Nurul Shahira binti Ibrahim, me, Siti Nurul Ain binti Ali, Sumayban, and Wan Muhammad Shafiq bin Shawaluddin. The contents of our presentation is introduction, methodology, results and calculation, discussions and conclusions, and the last one is differences. The objective of this experiment is to compare the discharge coefficient of different types of flow measurement methods, and the theory is many types of device using the principles of Bernoulli equation has been developed to measure the flight velocities and flow rates. But in this experiment, we will only use three types of flow meter, which is orifice plate, nozzle, and venturi. And these three types of flow meter will use the same physical principle, which is increase in velocities will resulting in decrease in pressure. The first one is orifice plate, where it is a restriction with an opening smaller than pipe diameter that is inserted in pipe. As you can see at the picture that I have put in this slide, the orifice meter will make the opening of pipe become smaller and increase the velocities of flight and decrease the pressure. Flow rate can be calculated from pressure drop across the orifice plate, which is P1 minus P2. And orifice plate is commonly used flow sensor, but due to the turbulence around the plate, it creates a large non-coverable pressure and make the energy consumption become high. Bernoulli equation can be applied if the assumptions of the flow is horizontal, which is Z1 equals to Z2, steady, inviscid, which means the viscosity of flight is equals to 0 and incompressible between point 1 and 2. And the theoretical fluid, which is QTH, can be expressed by cross-sectional area of orifice plate times with square root of 2 times with differential pressure between points 1 and 2 over density times with 1 minus cross-sectional area of orifice plate per cross-sectional area of pipe power of 2, where internal cross-sectional area of pipe and cross-sectional area of orifice can be obtained by pi times r squared. And then the differential pressure between points 1 and 2 also can be replaced by density times with gravity constants and times with differential height in millimeter between points 1 and 2. And the coefficient of discharge CD equals to Q actual over Q theoretical, where Q actual can be obtained by volume divided by time. The second device is nozzle, where nozzle applied same principle and calculation as orifice plate, but it only changed with the A2, which is cross-sectional area of nozzle. And the difference between orifice plate and nozzles are only the shape of the restricted opening, where as you can see at the picture that I have put in here, nozzle have a quarter ellipse restricted opening. Okay, the last device is venturi, where it consists of converging section that will increase the velocity of flow and reduce the pressure. As you can see at the picture here, it also will turn to the original dimension of pipe by diverging the diffuser. And in venturi, discharge coefficient can be calculated by measuring the pressure differences, and it also an accurate method of flow measurement because of the energy loss is small. It also uses the same principles and calculations as nozzle and orifice plate, where it will change in V2, which is the cross-sectional area of venturi. And next, I will pass to the next presenter.
Alright, for the experiment, I'm gonna explain more on the methodology for apparatus and procedure. So, for apparatus, it involves 11 apparatus, which is multi-tube manometer, orifice plate or nozzle, water inlet, main switchboard, flow control valve, venturi, sump tank, water outlet, gate valve, rotometer, ventilation valve, black and white. Okay, so now I will explain more about the procedure that we have been through during this experiment. For the first step is the orifice was ensure that it was properly fixed at its position and the manometer was fastened H1 and H2 to the orifice plate. For the second step is flow control and gate valve were closed. And then the main switch and the pump were turned on. The third step is the flow control and the gate valve were slowly opened at the same time until it reached the maximum opening level until the water in the manometer overflows. For the fourth step is the ventilation valve, which is black, was opened by turning it anti-clockwise to release all bubbles, if any, in the system. It is to avoid the parallax error during this experiment. For the fifth step is the ventilation valve black was closed, and after that the gate valve was closed. The pump was turned off. The sixth step is the ventilation valve white was slowly opened until the minimum water level of 30-40 mm was reached, and then the pump was turned on. The seventh step is the gate valve was slowly opened until level water in H1 reached maximum 390 mm and manometer H2 is at minimum level. All the reading was recorded in multi-tube manometer H1 and H2 and rotameter QX. For the eighth step is all readings were recorded in multi-tube manometer, which is H1 and H2 and rotameter QX. The gate valve opening were adjusted or reduced for 5 different QX values. For minimum QX value shall be approximately 200. The ninth step is the gate valve was closed and the pump was turned off. The manometer tube H1 and H2 were removed from orifice plate. The 10th step is orifice plate was changed with nozzle and the step 1 to 10 were repeated. Meanwhile, for the venturi, the manometer tube were connected to H1 to H2 and similar step of 1 to 10 were applied. For the last step is all the manometer tube was removed from the system after finishing. The flow control valve was closed and the pump and the main switch were turned off. So now I will pass this presented to my new member.
My name is Sumewan and now I will be presenting the result. First, we have to find the theoretical flow rate, the actual flow rate, and also the coefficient of discharge by using these formulas. This is the result from our calculation. To find the area, you have to use the formula area equals to pi r squared. Then you have to find the difference in height, which is delta H. For orifice plate and nozzle, you have to take H1 minus H2. But for venturi, you have to take H1 minus H3. For table 1 is the data for orifice plate, table 2 for nozzle, and table 3 for venturi. Next, to plot the graph, we have to find log Q actual and log delta H. Log Q actual as the x-axis and log delta H as the y-axis. This is the data and the graph for orifice plate. The second one is nozzle. We also did the same. We find the log Q actual and log delta H and we plot the graph. The third one is for venturi. As you can see from the graph, we get a straight line. Lastly, we will calculate the average CD for every type of flow rate. For orifice plate, we get 0.358, and for nozzle, we get 0.761, and for venturi, we get 0.902. That's all from me, and I will pass the presentation to my next teammate. Thank you.
Hello and hi everyone, my name is Nur Shahira binti Ibrahim. I will present about discussion and conclusion for group 6. So we go for discussion first. So the difference on water level H1 minus H2 in manometer, which different type of flow meter. We let answer with pressure losses associated with the type of flow meter. So from the result, we get the value H1 of all type of flow meter is always greater than H2. So from Bernoulli equation, we got P1 over rho G plus V1 squared over 2G plus Z1 equal to P2 over rho G plus V2 squared over 2G plus Z2. So as we know Z1 equal to Z2, So it will be P1 over rho G plus V1 squared over 2G equal to P2 over rho G plus V2 squared over 2G. So we take equation Q equal to AV. So A2 less than A1. So V2 larger than V1. So from there, V2 larger than V1. So pressure losses occur, that is P2 smaller than P1 to balance the Bernoulli equation. So that is the proven how H1 is greater than H2. So A2 is smaller than A1, P2 is bigger than V1, P2 is smaller than P1, and H2 is smaller than H1. So for the second is the difference in discharge coefficient value for each of the flow meter and the ranking of the flow meter according to their accuracy. So here is the table for CD of orifice plate, nozzle and venturi meter from first reading until fifth reading. So we calculate out of this and we get the CD in this result, and we get the average of orifice plate is 0.35x, for the nozzle is 0.761, and for the venturi meter is 0.902 for the average CD. So from there we know that most accurate flow meter is venturi meter. This is because the average CD of venturi meter is 0.906, closest to 1 compared nozzle and orifice plate. The average CD of nozzle is 0.761, which is smaller to 1 due some error occur. The average CD of orifice plate is 0.35x, smaller than 1, that actual flow rate bigger different from theoretical flow rate. So the accuracy of flow meter is venturi meter, and then nozzle, and then orifice plate. So the last question in this discussion is factor contributing to error or accuracy in experiment data, the possible recommendation to improve the existing result. So from the error, I got is a bubble present in the apparatus that affect the reading of height of manometer. The water meniscus form caused the reading of the manometer slightly high. The observed ice not perpendicular to the scale during that reading that made parallel error occur. Unstable flow rate that the head value keep changing and make observer difficult to take the reading. Limitation in the time response. In human that is observer do start and stop the stopwatch at the exact time. So for the recommendation, make sure there are no air bubble in tube to get accuracy reading. And second, the parallel error can be reduced by put white paper behind the ruler to get the perfect reading. Third is flow rate of water must be constant during experiment by fully open the valve in every pipe. And then the observer eyes must perpendicular to the scale to avoid parallel error. And the last one, the observer must take the reading repeatedly to get an average and accurate reading. So here we go for conclusion. So for the conclusion, the most accurate flow meter is venturi meter is due to the average CD of venturi meter is 0.906, the closest to the one, while the nozzle get average CD is 0.761 and the orifice plate get average CD is 0.35x. So the average CD of nozzle and orifice plate is smaller than 1, so that's why nozzle and orifice plate are less accurate flow meter than venturi meter. So here is some error in the experiment that we took in this conclusion, and also the recommendation in experiment we took from the discussion and take in the conclusion. So here is some reference that we got to settle this experiment, and that is from us. Thank you.